All right, so first of all, let's look over the criteria for a function to determine if a function is continuous at some x value a. Well, the function has to exist at a. If it doesn't exist, if f of a does not exist, we call it an infinite discontinuity, because if f of a doesn't exist, it means we tend to have a vertical asymptote. The limit as we approach a has to exist. If it doesn't exist, the graph has a jump. The limit from the left and the limit from the right are different, which means you have a jump. Yeah. And third thing is 1 and 2 have to equal each other. If they don't equal each other, then that eliminates holes. If they don't equal each other, we call it a removable discontinuity. So, why are these two functions discontinuous at x equals 3? Well, you follow these steps. Does f of a exist? Okay, so f of 3, does it exist? Well, we get 3 over 3 minus 3 is 0. And when we have division by 0, which we studied earlier for limits, that gives it, when we have a non-zero number over 0, it tends to give us an asymptote. Yeah? So this does not exist, that's why it's discontinuous at 3. So we would say it doesn't exist because it has an infinite discontinuity. So this is the reason why this function is discontinuous at 3. What about this function? This is a little piecewise function. All right, so does f of 3 exist? Well, when x is 3, the value of this function is 7. So yeah, it does exist. So there's no asymptote. Does the limit as we approach 3 of our function, does that exist? Well, keep in mind the limit, we're getting closer to 3, but we're never actually equaling 3. So because we are not actually 3, this is the value, the function we want to use, this top part of the function. So when x gets closer to 3, this gets closer to 3 minus 2 quantity squared plus 3. Well, 1 squared is 1 and 1 plus 3 is 4. So the limit exists. So we don't have a jump. What about the third step? Are these two equal to each other? Well, 7 is not equal to 4. And this is the reason why, step 3 is the reason why this function is discontinuous at 3. And we say the reason is because it has a removable discontinuity. So this is a removable discontinuity. So those are the reasons why. Again, if we took this limit and the limit didn't exist, yeah, then the function would have a jump, and that would be the reason why it would be discontinuous at 3. But again, this problem, the limit did exist. It's just that the function and the limit are not equal.